Hello friends, now in this video we are going to learn about the classification of isomers. Now here you can have a view about the schematic representation of complete classification of isomers. However, in this video I am going to deal in brief of each and every topic. A detailed video of all these topics will be available in the coming videos. So friends, please don't forget to subscribe to the channel and get updates. Now coming to the topic, isomers. So what is the general idea of what we have about the isomers? Isomers are having same molecular formula. So molecular formula will remain same. What changes then? Different structures. So they differ in the structure, but molecular formula will remain same. What we call them as isomers. So this is the general idea what we have. Let us continue with this idea now. Now coming to the classification of isomers. Broadly, isomers are classified as structural or constitutional isomers and stereoisomers. Now let's try to have a difference. What is the major difference between these two kinds of isomers? So first, coming to the structural or constitutional isomers, these will have different IUPAC name. The IUPAC names will be different for the structural or constitutional, whereas stereoisomers same IUPAC name. So what could be the reason for maintaining different IUPAC name here and same there? So now let us see. So here they will have different connectivity. The isomers will have the different connectivity, whereas in the stereoisomers there will be difference in the spatial arrangements. So spatial arrangement of atoms or groups will be differing. Now let's try to learn about the first two kinds of structural isomers, structure and chain and position. Now here you can have few examples. Now how to identify chain and position isomers? So in case of chain isomers or position isomers, first you have to learn about naming the compounds. Now we can cancel here because both look same. So now I am calling it as first, second, third and fourth. Now let us try to name this. What is this compound is called as? How many carbon compound it is? 1 2 3 4 5. So 5 carbon compound with methyl side chain. So now we can call it as what? 2-methyl pentane. Likewise, try to name the each and every one. So now if you look about these examples, now let us try to compare with the first and third. So between 1 and 3, 1 versus 3, what you can observe here? So 2-methyl pentane and 3-methyl pentane. If you observe here, the parent chain is pentane. The parent chain is not changing. What is only changing? The side chain name is changing. So 2-methyl and 3-methyl. So here only the position of the methyl side chain is changing. So we can call that 1 and 3 as position isomers. So these are called as what? Position isomers. Now coming to the 1 and 2 examples. Now if you observe the 1 and 2 examples, what you can observe here? Here if you see, it is a pentane, here it is a butane. The parent chain itself it is changing. However, the side chains are also changing. Now if you observe directly the parent chain, here pentane and butane, we can directly call it as what? Chain isomers. So when the parent chain is directly changing, then we call it as what? Chain isomers. So if the parent chain is remaining same but the side chain, even position, what should be same? Same parent chain and side chain. Parent chain and side chain should remain same, but the position of the side chain should change in case of position isomers. So what about the chain isomers? So parent chain and side chain will be different. Parent and side chain will be different in case of chain isomers. So this is how we can identify which are the position isomers as well as chain isomers. Now let us try to take the example of 2 and 4. Now if we observe the examples 2 and 4, what kind of isomers here? Both, if you observe here, both these are what? butane, that is parent chain is same. Now what about the side chain? Side chain are also same, dimethyl and dimethyl. What is changing then? Only the position of these groups are changing, so therefore we can call 2 and 4 as position isomers, isn't it? Now what about third and fourth examples? What about third and fourth example? Here it is a pentane, here it is a butane, so completely the parent chain itself is different, so then we can call it as what? Chain isomers. So this is how we'll find the difference between chain and position isomers. Now let's switch over to the functional isomer. Now here you can observe, friends, with examples the functional isomers. Now if you observe here the two examples for functional isomers, what the change you can observe here. So in this example, this is called as what? Propanol, is it? And otherwise in the name of positions, what you can say here? Propane 1-ol, isn't it? So what about this one, friends? This is prop 2-on. Now in this, what is the formula here, friends? Here it is 3 carbon compound, and how many hydrogens you can observe? 3, 4, 5, 6, 7, 8. Oh, now here also the same formula, C3H8O. So the molecular formula is remaining same. So what is differing here? Because of presence of OH hydroxyl functional group, it is called as alcoholic functional group, is it? OH hydroxyl group, so then it is called as alcoholic functional group. Here presence of oxygen on either side of alkyl groups, we call it as what? Ether functional group. So the functional group itself is changing in these two examples. So these kind of isomers we call it as functional isomers. And now coming to the metamers. So what are metamers? So metamers are those which differs in the number of carbon chains on either side of a functional group. Now if you observe a functional group, what kind of functional group here it is? It is a ether functional group. So on either side of this ether functional group, there are 2 carbon chain on either side. Now coming to the next example, what you can observe here? So to this ether functional group, to the left it has only 1 carbon chain, and to the right it has 3 carbon chain. So therefore this kind of isomers we call it as metamers. So metamers are also a kind of position isomers, isn't it, friends? So here the ether functional group is present at the third position, and here second position, here it is present on the first position. So these are also a kind of metamers, are a kind of position isomers. Now switching over to the tautomers. So tautomers are those the tautomerism exists between two compounds that remain in the dynamic equilibrium with proton dislocation. So now if you observe this example, so this is a keto functional group and this is what? Enol. So here if you observe, this double bond shifts over here and one of the proton dislocation takes over to this oxygen atoms, and this results in this form. So keto will try to convert into the enol form, or enol will try to convert to the keto form as the requirement. So here a dynamic equilibrium exists between these two groups, so these two compounds, by just dislocation of this proton atom. So this kind of conversion from keto to enol form, we call it as what? Tautomerism, and these two can be referred as tautomers.